All right, welcome. This is 9.3, factoring when a equals 1. So in 9.2, up here, okay, we did everything when a is greater than 1. And again, a is like the leading term for a quadratic, or the leading coefficient. So like ax squared plus bx plus c. So when a is greater than 1, that's what we've been doing here. So here we have 8, here we have 3 as the leading term, here's 5 as the leading term, if you can even see that. Okay, but today we're going to be focusing more on when a is 1. And there's something special about it when a is 1, so let's see what we can figure out. All right, so let's factor out each of these expressions. Okay, and we did this in our mini test. So what we do, first thing is glasses. We multiply the first and last term. That gives you negative 9x squared. Let me zoom that in for you. Okay, and then we want to find two things that multiply to give us that, and also add or subtract to give 8x, our middle term. Okay, so again, I would always recommend that you try doing factor pairs, writing down the factor pairs. So for 9, we would want to do 1 and 9, and we could also do 3 and 3. Those are the only factor pairs. And then we need to see which factor pair can we use to add or subtract to give us 8. Okay, so 3 and 3, there's no way we can get 3 and 3 to give us 8. Even if you added or subtracted, you'd end up either getting 0 or 6. Okay, but with 1 and 9, we can do 9x minus 1x, and that would give us 8x. All right? So in the past, when a is greater than 1, we would take this and we would substitute that in for the middle term. Because we just said that 8x is equal to 9x minus 1x. And then we'd still have our x squared and our minus 9. Okay, so we just found those two things that will break that 8 in half so that we can do grouping. So after that point, we would, let me just change this really quick. Okay, so we would cut it in half and then we'd do grouping. So the left side would take out the greatest common factor. So we could take out an x. You can't take out any numbers except for 1. Okay, but we'll take out an x because it's our smallest amount. So we'll have x, and then we'll divide everything by x to give us what's left after we take out x. So if we take out 1x, we'll end up having an x plus 9 left. And then we do the same for the right side. So again, negative 1 would be our greatest common factor. Since it's a leading term, we would take out a minus 1, and then what's left would be x plus 9. Okay, and we talked about how these are the same, and we would factor out the greatest common factor for the whole thing. So the whole thing, we could take out an x plus 9 from both terms. So it would have x plus 9 out in the front, and then what's left would be x minus 1. Okay, and that would be your answer. Okay, so what I'd like you to consider, well, let's do another example. Okay, so we'll try again. We'll do glasses, that gives us 6n squared. Two things that multiply to give us that, and add to give us the middle term. Okay, we could do factor pairs again if we wanted. We could do 1 and 6 or 2 and 3. Okay, the only one that will make that work would be 1 and 6, but it's negative 7, so what do the signs need to be for 1 and 6? If we did 1 plus 6, then that would give us a positive. So to make it be a negative 7, both terms would need to be negative. And then we'd do the same thing. So we'd plug that in, we'd do n squared is the same, and then minus 1n minus 6n plus 6. and then we'll do grouping. So the greatest common factor for the left side would be n, and what's left, and I always write this to divide it by 6. I imagine eventually that with enough practice you probably would just do it in your head, and that's okay. But if you don't feel like you've got it yet, then please write those down. So n squared divided by n gives you n, and negative 1n divided by n leaves you with a negative 1. And we'll do the right side. So it looks like we can divide both terms by 6, and we also have a leading negative, so we'll do a negative 6. So we'll have negative 6n divided by negative 6 gives you n, and then 6 divided by negative 6 gives you negative 1. And again, what's inside those two parentheses are the same, so we can factor that out from both of those terms, so n minus 1, and what's left would be n minus 6. Okay? A couple more examples, and then we'll talk about how we can use a shortcut. Maybe you've already figured that out. So here we have negative 56m squared. Add up to give us negative m. It's the same as negative 1m if that helps. Okay? And then maybe we'll do factor pairs. So 56, we could do 1 and 56. 2 and 28. 3 doesn't go in. 4 goes in. And I would just don't spend time trying to look at or figure it out in your head. Just grab a calculator. So like 56 divided by 3, that gives you 18.6666666. So obviously it doesn't go into there. But if we do like 56 divided by 4, that gives us 14. So just use your calculator and save yourself some time and make sure you don't make any mistakes. Okay, we're still not there yet, so let's try 5. 5 doesn't go in. 6, that doesn't go in. What about 7? 56 divided by 7, well, that gives you 8. Okay, so looking at those factor pairs, and I know a lot of this, we've done this so many times, but I just want to make sure. If you feel like you're good with this, you're always welcome to go ahead. So here we have our factor pairs. We need to see which of these can we use to give us a negative 1m. Okay? All right, and obviously there's no way we could do it with that. I mean, if you did 56 minus 1, that gives you 55. That's not even close. You could do something like 2 minus 28. Well, that would give you negative 26. You could maybe get 10 with that. And then with this one, we could make that work. We just need to decide which number is going to be negative or positive or both negative or both positive. Okay? So again, we just need to combine them using addition or subtraction. So it looks like we would need to do negative 8m and a positive 7m. Okay? And then we multiply those together. That gives us the negative 56 m squared. And when we add those, it gives us the negative 1m. Okay, so what we did in the past is we just substitute that in. Again, a lot of mathematics, I can't even talk, a lot of math is just repetitive. Just practice and practice, just like anything else. Okay. All right, so then we do the left side. We can take out an m. Leaves us with an m minus 8. And on the right side, looks like we can take out a 7. So 7, and that would leave us with a m minus 8 again. Okay, so now these are the same. We can factor those out from both of those terms. Gives us m minus 8. And then what's left would be m plus 7. Okay, looks like we have We get all of those? No, we have one more, D. Okay, so one more time. So we have negative 8x squared, add up, or to multiply to give us negative 8x squared, and add to give us 2x. So here we can come up with factor pair again if you need. So for 8, we could do 1 and 8, or 2 and 4. And that's it. 3 doesn't go into 8, and then we're back to 4. So can 3 and 4 give us 2? So you'd say yes. 2 would just need to be negative. So we could do 4x minus 2x gives us 2x. And if you multiply those two terms together, it gives us the negative 8x squared. Okay, so then we plug that in. We'll do plus 4x minus 2x minus 8. Cut it in half. Here we can take out an x. Leaves us with x plus 4. And then here we can take out a negative 2. And that ends up giving us x plus 4. So we'll end up getting x plus 4 times x minus 2. Okay? Now, look, and I'll just read this to you. It says, look back on all of the examples that you did. Look at patterns that happen in the process. Write down your, or anything that you notice. So looking at all of these, do you see a pattern? It may take you a minute, and pause if you can. Okay? But there is a relationship between the two numbers that multiply and add and your answer. Okay, what do you notice? Okay, hopefully you notice that the numbers in your answer are the same numbers that's in the two things that multiply and add. Okay, so like here we have x plus 9, and here we have a 9. Here we have x minus 1, well we have a minus 1. Okay, so that is the pattern. Okay, that when, and this only applies when a is 1. Okay, so the pattern that we found is the factors are the answers. Okay, so here we had factor pairs. The factor pairs that worked, the 9 and negative 1, is the answer for our parenthesis. Okay, so I'll give you a few examples. Well, let's just fill this in. It says, turns out that sometimes we can use a shortcut to factor. We can use this shortcut only when a is equal to 1. Okay, so don't try and do it any other time. A has to be 1 to make this work. Okay, so here's the shortcut. So you multiply, that gives you the 10x squared. You're still going to need to do this. And you need to find the two things that make that work. All right? So you could do factor pairs if you wanted to, because that's what we really need. 1 and 10, and 2 and 5. So this is the one that will work. So 2x plus 5x. And these, the 2 and the 5, is going to be your answer. So you've noticed here, again, I already explained that, but what you're going to do is you're going to make your two parentheses. Here we're using x's for our variable, and then we're going to plug in our numbers, our coefficients. Okay, so that would be a positive 2 and a positive 5. So plus 2 plus 5. And that's it. Okay, so you don't need to do grouping, although if you want to do grouping, you'll end up getting the same answer. So here we'll try one more time. So negative 32 x squared, and add up to give us 4x. All right, so we'll do factor pairs for 32. We could do 1 and 32. We could do 2 and 16. 3 doesn't go in. 4 and 8. Looks like that would be our best bet. 1 will need to be negative. So something like 8 minus 4. Okay. Since A is 1, there's not a number in the front. Okay. Then we can write our two parentheses, and we'll do x plus 8 because it's a positive 8, and x minus 4 because it's a negative 4. All right, and that's it. All right, so I guess I didn't ask you to pause and practice, but please try and do that. I mean, do your homework. If you have any questions, let me know on those. Okay, so now that we've practiced when A is 1, let's combine this with the greatest common factor. All right, so we really worked a lot on the greatest common factor in Unit 8. So when you have terms like this has 3 terms, we will want to take out the greatest common factor before we do glasses. So, or just like, yeah, all right? So it will make it much easier if you will do that. All right, I guess I didn't fill this in. We can, oh yeah, it says, remember, you can still use the shortcut if and only if you factor out the greatest common factor first. Okay. All right. So make sure you do that. You can't use, like how it is right now, we can't use the shortcut because A is 2 right here. But if we can take out the greatest common factor first, well, what is the greatest common factor for all 3 of those terms? Well, here it's 2. So we can do 2, and then we'll just divide everything by 2, and that leaves us with v squared plus 9v plus 20. Okay? And we're just going to keep this on the side, but now what's inside the parenthesis, A is 1. There's not a coefficient in front of the v squared. So now we can use the shortcut. We can do the glasses. That gives us 20v squared. 2 things that multiply to give us that, and add to give us 9v. So we can do factor pairs 1 and 20, 2 and 15, or 2 and 10, 4 and 5. I think those are the only factor pairs. And here you'd probably say, well, 4 and 5 gives us 9. So we'd have 4v plus 5v. And again, if you wanted to do grouping, what you'd want to do is you'd plug that in here. You'd probably just only look at this part, and then when you're done, you would need to put this 2 in the very front. So you'd end up having, well, I guess we'll get the answer in just a minute, so just hang tight. So we found the 2 things, and A is 1, so we can write our 2 parentheses. Since we're using v's, we'll plug in v's. And then since it's a positive 4, we'll do plus 4. And it's a positive 5, so we'll do plus 5. And like I said, this greatest common factor will need to come out in the front. Okay? All right. So I would love it if you can try a few, maybe B and C, and then come back to me and see what you got. Okay? So here we are looking at this. Greatest common factor, well, it looks like 3 can go into all 3 of those, so we'll have 3, and then we'll divide everything by 3. That leaves us with x squared minus 4x minus 12. Okay? So this is one of the main reasons why, like I said, you can do it later, but it's really nice if you take out the greatest common factor first. If you did this and multiplied those together, I think that ends up giving you like 108, and that kind of makes it hard. But if you take out the greatest common factor first, here now when we do glasses, we just have to work with a negative 12, which is much easier to manage. Okay, so for 12 we could do 1 and 12, or 2 and 6, or 3 and 4. Okay, so which one will make that work? Looks like to give us 4 we could use 2 and 6. It's like the only one we could do. And since it's negative 4, we're going to need to have negative 6x plus 2x. Okay? Okay, and now since a, the leading coefficient, is 1, or there's not a number there, then we can use the shortcut. So we'll have the 3 out there in front, and we're doing x's, and we have a minus 6 and a positive 2. And that's it. Okay, so hopefully you got that one. Here's C. Here, again, take out the greatest common factor. And a lot of people forget that that's part of the greatest common factor. So we'll take out a negative. You could even say a negative 1 if it makes you feel good or better. Then we'll divide everything by a negative 1. And that leaves us with x squared plus 5x minus 36. Okay? Now the leading coefficient is 1. Okay, it can't be negative 1. It's got to be positive 1. Then we can use the shortcut. So here we've got negative 36 x squared and add up to give us 5x. So what's going to make that work? Well, maybe let's do factor pair again. So for 36, we could do 1 and 36. We could do 2 and 18. 3 and 12. 4 and 9. 5 doesn't, 6 does, so 6 and 6. And that's it. Okay, so it looks like the ones we're going to want to use is 4 and 9. We could do 9x minus 5x, or 4x, sorry. 4x, and that leaves us with 5x. And if you multiply them, that works out great too. Okay, so since we took out the leading negative, or the greatest common factor, same thing I guess, then we can write down use our shortcut. So we have our 2 parentheses. Our greatest common factor here was a negative 1, or just a negative, and we'll just do x plus 9 and x minus 4. All right. So like here, for this one, if you didn't take out the leading negative, then you're going to run into issues unless you do grouping. So if you left the x and you did grouping, then you would have been okay. Okay. All right, and here's one more. You're welcome to just pass this if you'd like. Looks like here we can take out a negative 4. That leaves us with y squared. I'll just write these all. I guess I'll write this down. Negative 4. That gives us a positive 5y, and then 56 divided by 4. 56 divided by 4, or negative 4, that gives you negative 14. Okay, so we took that out. Now a is 1, and we can use the shortcut. Multiply those together, negative 14y, and 2 things that multiply to give us that, and add to give us 5y. We can do factor pairs for 14, 1 and 14, and 2 and 7. Looks like that would work if we did 7y minus 2y. And then we can use our shortcut. So negative 4 is in the front. Have our 2 parentheses. We'll do y plus 7, because it's a positive 7. And then we'll do y minus 2. Okay? And again, if this just not clicking, but you're good with grouping, then I would just take that and plug it in here and do that grouping and just make sure you put the -4 in front. Okay? But it does save quite a bit of time if you can use the shortcut. Okay? Here's another one. This one's a little different. So I'll put a little star on that because it's a little different. Okay? Here we also have a variable that we could take out for the greatest common factor. So it looks like we could take out a 3a, right? And that would leave you with a squared minus 2a, and then 24 or 240 divided by 3, that gives you 80. So plus 80. Okay. So just a note. You cannot do glasses or I guess maybe I should rewrite this. You can only do glasses or factoring like that when it's a quadratic, meaning that the highest exponent is x squared. So here, if you tried to do glasses with this problem and did something like this, you would not be able to do it. Wouldn't work. Okay, so we would have to take out, at least you'd have to take out the a. Okay, so here we go. We can do glasses now. We can use the shortcut because a is 1. So we get 80 a squared, add up to give us negative 2a. Okay, just for the sake of time, for 80, you could do 1 and 80, and you can keep going until you'll end up getting like 8 and 10. Okay, so yeah, sometimes you have to try 8 times to get the final thing, and that's okay. Just keep trying, make sure you checked all of them, right? So here we would need to do like negative 10a and a positive 8a. Okay, and since a is 1, or the leading coefficient is 1, then we can just write down our 2 parentheses. The greatest common factor will stay in the front, and then we'll do a minus 10 and a plus 8. Okay? Sweet. Okay, it looks like there's one more. I'll give that a try too. Looks like we could take out a 2. Use this with x squared plus 8x and minus 33. So if you haven't practiced, paused and tried, please try and make sure you've got this. Okay, so here we multiply, that gives us negative 33x squared, and add up to give us 8x. Okay, we'll use some factor pairs, so maybe for 33 we could do 1 and 33, or 2 doesn't go in, you could do 3 and 11, and I think that's it. So 3 and 11 will work. We just need to do 11 minus 3, so 11x minus 3x. And then we'll write our 2 parentheses. Greatest common factor will stay in the front, don't forget that. And then we'll have x plus 11 and x minus 3. Okay, and that's those values that you plug in. Okay, some people ask, well, do I need to write down the x for that, like for here? Do we need to write those? Okay, I mean, you don't necessarily need to, but I have a lot of people forget that when you have to do grouping, you have to have those x's. Okay. Otherwise, you'd get something like x squared plus 11 minus 3 minus 33. And then you're into all sorts of mess. Okay? So make sure you carry those x's, even if, because I mean, sometimes you're not sure if you can use the shortcut or not. So, or I guess you already know that if you factored out the greatest common factor. So anyways, I would suggest you always write those down just for practice. Okay? Then we have two word problems. Okay? And these aren't too bad at all. All right? It says a square of an area. Square has an area. So here's a square. It has an area. Okay? An area is length times width. Okay? So it has the area of, so the area here is x squared plus 10x plus 25. Okay, and they want us to write an expression in terms of x for the possible length and width of the square. Okay, so basically for all these types of problems, you're going to want to do factoring, because that's what our unit is factoring. So here, we're really just going to do the same thing that you've always been doing. You're going to do glasses. You'll get 25x squared and two things that add up to 10x. Okay, so for 25, for factor pairs, you could do 1 and 25 or 5 and 5. Okay, and we'd do 5x plus 5x. And then we can use the shortcut. So x plus 5 and x plus 5. Okay, so here we have two binomials, okay, and these are basically your length times width. So you could say the length could be x plus 5, and width is also x plus 5. Okay, you don't necessarily need to have that be equal to, but okay. So anything like that is fair game for the test. But really what you're doing is just doing factoring. The wording isn't nearly as important as some other word problems. Okay, so it says the Johnsons are putting in a fence in their backyard, but they're very picky with the ratio of the fence dimensions. This, they want to make sure that the area of the lawn is always represented by this quadratic. What expression could represent the dimensions of the fence? So it's basically the same thing. The area is this quadratic, and if we factor it, we'll end up having two parentheses that will be our length and width. Okay, so here we'll just do that problem. We'll do glasses. That gives us 20x squared. We need two things that add up to give us negative 4x. So we could do factor pairs. We could do 1 and 20, 2 and 10, 4 and 5. Okay. Should I do something wrong? That's embarrassing. 20x, 1, 20, 2 and 10. 3 doesn't go in, 4 does. It's 4 and 5. I'm guessing there's probably a mistake in this problem, because there's no way to get you negative 4. Well, how about we'll just change that and be something else, like maybe this should be a negative 8. Let's give that a try, okay? Sorry, my bad. So if I did not make a mistake and I just don't catch it, let me know. I'll give you extra credit. All right, so here we go. So it looks like we could do 10 and 2 with that negative 8. Would do negative 10x plus 2x. I guess that would need to be negative 2. Interesting. Okay, well, let's just change that too. Anyways, so you'd end up doing the same thing. You'd say, well, a is 1, so we can just get x minus 10 and x plus 2. And that would be like your length and width, okay? So we'd write length is x minus 10, and we could say width is x plus 2. And it really doesn't matter which is length and which is width, okay? Okay, so if you have any questions, let me know. I'd love to help you out if you get stuck. Oh, they changed it. Yeah, that's it. So, sorry. So this changed, somebody changed it to 9, and I just didn't fix that, okay? Anyways, okay, well, sounds good. And we will do another lesson after this, do a review, and then I think we'll be taking the final test for this unit. See ya.